The Tape APB plugin from DSP is an analog emulation of magnetic tape recording systems that utilizes a 4-stage analog process composed of the APB's real analog circuitry to recreate the compression-like effect of recording to tape. The APB is DSP's analog processing box, and it's the world's first programmable analog processor. Inside, it includes premium analog components, multiple analog saturation circuits, and AKM 32-bit DAC and ADC converters that process your audio straight from your DAW via a Thunderbolt 2, 3, or 4 connection. These features work together with the diverse library of APB plugins to control these analog circuits, providing the convenience of using presets, complete and instant recall, and automation with the sound of real analog hardware. The Tape APB plugin isn't just another emulation of the classic magnetic tape recorder and reproducer that reigned supreme long before the days of digital audio workstations. Tape is a real analog process, just like a reproducer itself. Like other APB plugins, the Tape APB plugin uses the DSP patented APB technology to leverage the world's first programmable analog processor circuits, sample-accurate control, and otherwise massively over-engineered system to glue any mix together. It also uses some of DSP's 25 years of experience and counting in the digital realm to create tones unique to the Tape APB plugin as well. On the UI, the user has control over 2 different tape types, 2 playback head configurations, low-end bump amount, and the low-end roll-off frequency. The amount of tape compression is even user controllable, along with the input and output levels. The user may also use dual VU meters to monitor input, output, and gain reduction levels. Let's check out Tape's controls in more detail, and then have a listen to the plugin in action. The left and right sides of the plugin are mirror images of each other, so we'll start on the left side of the plugin UI, and then discuss the options in the middle of the UI. Starting with the black knobs, we have roll-off, bump, and comp. Roll-off is the frequency at which playback reproduction levels begin to reduce. This phenomenon is generally caused by increasing playback speed, but in tape, it is reduced to a user control. Next, bump designates the amount of ripple and the low frequency response near the frequency selected by the roll-off control. This emulates the playback head ripple that is generally caused by the width of each track on an actual reel of tape and the tape machine itself, but just like the roll-off control, this sound is reduced to a convenient user control. The last black knob is comp, which is the amount of dynamic range compression caused by the tape type selected by the tape switch directly to its left. Speaking of which, each side of the plugin features 2 switches, tape and head. Tape selects the physical tape type or formulation. Both of these options, GP9 and 456, encompass the sounds of the 1970s and 80s. The 456 formulation has a larger tape compression and saturation region and is more prone to pumping tape compression effects, while the GP9 formulation has a much smaller tape compression and saturation region with a slightly wider dynamic range. The head switch selects the playback head configuration. The 2 options, 80s and 70s, incorporate characteristics of magnetic tape machines made during those eras. 80s has a much narrower low-end boost and a steeper low-end roll-off for an overall tighter sound, while 70s has a much broader low-end boost and a broad low-mid scoop that, when combined with the boost, is more likely to result in pleasant tape-like overloading. The final knobs on the UI are the in and out knobs, which are white and orange respectively. In designates the amount of gain at the plugin's input stage, and out applies the amount of gain at the plugin's output stage. Note that the tape algorithm is designed to prevent substantial overloading and will not generate all of the selected output gain if the signal level is already near the maximum dynamic range of the analog signal path. Now let's move on to the middle portion of the plugin UI, which includes some switches and VU meters. We'll start with the switches. First up is the VU meter mode selector switch at the top, which includes in, GR, and out options. Use this switch to select what type of level the VU meters display, the input level, gain reduction amount, or output level, respectively. This switch is mirrored on either side of the VU meters. The bottom left switch is the processing mode selector, which includes dual, SP, and MS options. While MS, or mid-side, is selected, the left side of the plugin UI will only process the mids of the input signal, whereas the right side of the plugin UI will only process the sides of the input signal. When the dual or SP mode is selected, the left side of the UI will only process the left side of the stereo field, and the right side of the UI will only process the right side of the stereo field. When dual is used, gain reduction will be applied to the left and right sides of the stereo field independently, and when SP is used, the plugin will apply the same amount of gain reduction to both sides of the stereo field. For SP, or stereo pair mode, the gain reduction amount is calculated by using the average amount of gain reduction that would otherwise be applied to both sides of the stereo field independently. The final switch in the middle section of the UI is the control linking mode selector, which has dual, L1, and L2 options. Dual allows for changes to be applied to the left side of the plugin without applying those same changes on the right side, and vice versa. Enabling L1 or L2 will result in linking the left and right sides of the plugin together, so changes made to the left side will also be applied to the right side, and vice versa. The difference between these two modes is how they behave when the user writes automation data for any tape parameters. Writing automation data while L1 is enabled will only write automation data for whatever control is being automated, while L2 will write automation data for whatever control is being automated in addition to its counterpart on the opposite side of the plugin. Tape includes two VU meters, one for each channel of processing, and they can show input level, gain reduction amount, or input level depending on the selection made in the previously mentioned VU meter mode selector. Our first example is a drum kit. Let's hear it with and without tape. In this example, we're bumping 73 Hz by 83%. We also have the compression turned up to about a 3.3 to 1 ratio, the 456 formulation is selected for more tape pumping effects, and the 80s head is giving us the perfect narrow boost and roll-off around our roll-off frequency. Lastly, SP mode is selected, which is why we're seeing the same amount of gain reduction on both the left and right channels. This sounds great as it is, but just to show off how fun tape sounds when you push it to its limits, let's do just that. For this next example, we have tape on a mix bus for a track that's already pretty funky, but let's make it even funkier by gluing it together with tape. This time around, we're bumping 57 Hz at about 65% with a 3 to 1 compression ratio. Additionally, our tape and head selections are both different for this example. GP9 is selected for a more subtle sound with less pumping effects, and the 70s head is giving us a more broad boost and roll-off. Here's another great mix bus example on a slower track, but this time we're performing some mid-side processing. Notice how the kick, snare, and mono guitar are all popping out of this mix a bit too aggressively with tape bypassed. But with tape engaged, they perfectly sit with the other instruments and the kick and snare get nice and snappy. Since we're in mid-side mode and not stereo, pair, or dual mode, the left side of the plugin is operating on the mids, while the right side is operating on the sides. In the mids, we have a 54% bump at 76 Hz to add some thickness to the mono elements of this mix, most noticeably the kick and bass. We're also compressing with a 3:1 ratio. On the sides, the low-end information is much less significant, so we have the roll-off set at 155 Hz with another 54% bump. Aside from that, the settings are the same as those of the mids, with the exception of a slightly lower compression ratio. To give you a better idea of what the mids and sides sound like on their own with tape processing, I'll turn down the mids to isolate the sides and vice versa. Next up is a deep male vocal that would benefit from low-mid thickness from tape. Here's how it sounds with and without the plugin.
There's nothing like your love to get me through the day. There's nothing like your touch to get me carried away. There's nothing like your love to get me through the day. There's nothing like your touch to get me carried away.
On this example, we're using stereo pair mode again with a 61% bump all the way up at 200 Hz. Don't be afraid to go for high roll-off frequencies on individual tracks like this one, as tape can add beautiful analog warmth to all parts of the low-end and low-mid portions of the frequency spectrum. To round out this example, we're also using the 70s head, the GP9 formulation, and a 2.75:1 compression ratio for some gentle tape compression. The Tape APB plugin is a great processor for adding a final touch to any track or entire mix. It applies the sound of tape compression, saturation, and warmth you've come to know and love, all with the help of real analog circuitry within the DSP analog processing box. Interested in learning more about tape, the APB, and the rest of our APB plugin line? Check out micdsp.com/APB for more info. Don't forget to like and subscribe for more MicDSP tips and content. Also, feel free to use the links in the description to follow us on other social media platforms. We will see you next time.